Hello, welcome to this lecture video. So today we will be talking about systems of linear equations. So in systems linear equations, we are very much familiar with what is the equations of a line or a linear equations in a variable x and y, and that is ax plus by is equal to c. This is if a and b are not both equal to 0. So it is if a and b are not equal to 0. Now we can also have a linear equation in variables x sub 1, x sub 2 until x sub n, and this can be written as a sub 1, x sub 1 plus a sub 2, x sub 2 plus until of course to our last value, which is a sub n, x sub n is equal to b. B is a constant term, and the coefficients of our variables x sub 1, x sub 2 until x sub n are a sub 1, a sub 2 until a sub n respectively. Now, this is called, of course, a linear equation because the highest degree is equal to 1. These are applied in different fields like chemistry, business, computer science, economics, electronics, physics, social sciences, and others. And they can be reduced to solving a system linear equations. So we have also what we call as linear algebra, which is of course why we are having this topic, because this arose rather from the attempt to find for the systematic method to solve this system. So the systems of linear equations. So just to have a review about this, given a sub x sub 1, a sub 2 x sub 2 until a sub n x sub n is equal to b, suppose we were able to find four solutions S sub 1, S sub 2 until S sub n. So these are of course called the solutions of the linear equations. So that is, for example, we have a sub 1, s sub 1 plus a sub 2, s sub 2 until a sub n, s sub n is equal to b. So if we're going to substitute this in place of our x sub 1, our x sub 2, and our until to the last number x sub n, you will get the values b. It satisfies, then it means that S sub 1, S sub 2 until S sub n are the equations, or rather the solutions of our systems of linear equations. So now let us move to some possible situations wherein when we try to figure out the solution of a system and find that there is a unique equation. So for instance, the graph that will show, for instance, that these two lines will intersect only at this point. So it means that there is a unique solution. So if it contains a unique solution, it means that it is called the system of linear equation is called consistent. Now, if we cannot find for a solution, it can be because the two lines now are parallel and they will never meet. So it means that there is no solution. It is called inconsistent. So you cannot find for the solutions. So is there also a way, or rather another case wherein you can find more than one values, or you can find solutions, the same solutions for equation 1 and equation 2 infinitely. So we actually have this situation wherein we say that it contains an infinitely many solutions. So let us change that. Infinitely many solutions. So for the case that it contains the infinitely many solutions, so of course we call it as infinitely many solutions, or because of course that they have the same line and it can just be represented in different equations. So an example for this, if you're going to figure out, for instance, so this is just the equation of negative 6x plus 2y is equal to negative 8, and the equation of 3x minus y is equal to 4. So if you're going to compute for this, you can get the same answer. So if you noticed here, it is just 3x is just divided with, or rather it is just multiplied with 2x, or rather 2, it is just multiplied with negative 2. So it is negative 3x minus y is equal to 4 multiplied by negative 2. And the answer is negative 6x plus 2y and negative 8. So it will, since it is the same line, so it will give you infinitely many solutions. And this can actually be transformed in matrix. And we call that as the augmented matrix. So if we convert it into matrix form, then we call the matrix as augmented matrix. So given, for instance, so let us consider an example here. So given, for instance, this equation, so we have here 2x plus 3y is equal to 8, and x plus y is equal to 3. Of course, you have to arrange it so it's x, y, and a constant. This can be transformed in augmented matrix by just copying now the coefficients. So that's 2, 1, 3, 1. And then let's place a line that will divide now our coefficient matrix with our constant matrix 8 and 3. And let's just place the bracket. So this, as mentioned, this is called the coefficient matrix, and this is the constant matrix. And we call this as the augmented matrix. Okay, so thank you for watching.